Hi and welcome. In this video, we are going to discuss about Codechef December long challenge question easy subsequence selection. Okay, the code is SUBSPLAY, SUBSPLAY. Okay, now before reading out the question, with the help of an example, I am going to explain you the question and then we will read it out. Okay, it will be very simple afterwards. Just with the help of an example, I am going to explain you whatever it is given in the question and what the question is asking. Fine, and then we will come and read the question back. So let's begin with this. I am explaining the question. This is problem understanding only, problem explanation only. Okay, but in a reverse manner. Fine. For example, there is a string. There is a string S that is given to us. Let's say the string is hello, HELLO. Okay. Next point is the string is hello. The length is n. N value is nothing but 1, 2, 3, 4, 5. N value is 5. Fine. We need to select two subsequence. We need to select two subsequence from this S. Let's say A and B of length K. Both should be of length K. Okay, and A should be equal to B. Both should be of length K and A should be equal to B. And these are subsequences, not substrings. Let me explain you the difference right now of subsequence and substring before moving any further. Okay, so if my string is nothing but ABC, correct? So in substring, what we have AB, we have BC, BC, we have ABC, we have A, B and C. Okay, how many? 1, 2, 3, 4, 5, 6. We have an empty one, that is nothing, and I think we have one more. No, this is fine. Okay, that is what we have. We simply have the continuous one. Okay, we can only select the continuous elements. We can only select this continuous element. In a subsequence, we can also select non-continuous elements. That is, we have A, B, C. We can select A, B, B, C. We can also select AC. A and C, non-continuous. Okay, that is, we cannot reverse the manner. We cannot select B, A. No, this is not correct. Okay, we cannot reverse the order, but we can select non-continuously. In a subsequence, we can select non-continuously. Okay, this is the first important point of what is a subsequence. Fine, we can select non-continuously. Just keep that in mind. Okay, now the next point after this is very simple, that we need to select two such subsequences. We need to select two subsequences, and both the subsequences should be of length K and both of them should be equal. Both of them should be equal. Now let's see. Now if I take the length K equal to 1, okay, what are the subsequences? It is H, E, L, L, O. Okay, these are my possible subsequences for length K equals to 1. Okay, now in this, for length K equals to 1, do I have anything of A equal to B? Yes, we do have. That is L and L. Okay, these are two different subsequences right now. Okay, and both are same, exactly same. So for K equals to 1, A equals to L and B equals to L. This can be a possible answer. Okay, now let's select for K equals to 2. The possible subsequences are HE, HL, HL, HO. This is one. Then we have EL, EL, EO. We also have LO and LO. Okay, now this L is of the index 2nd and this L is of the index 4. There are difference. Okay, we can also have LL. We can also have LL. Correct. I think this is enough for K equals to 2. Now which are the same subsequences for K equals to 2? So here we have HL and HL of length 2 that are exactly same. We have EL and EL of length 2, and we have LO, LO of length 2, and we have LL also. So if A is also LL and B is equal also LL, then they are exactly the same. We will come to this point that we cannot select such subsequences, but right now for the understanding, only if we know these points, then for K equals to 2, we do have the subsequences such that A equal to B and the length is K, and we have many of them. Okay, so for K equals to 2, we have such subsequences. Fine, let's go for K equals to 3, and it is hello. So it can be HEL, it can also be HEL. Now this is of the index 2, this L, and this is the index 3L. Okay, then we can have HEO. We can also have HLO, HLO, correct? Index 2, index 3, these are different indexes. We can also have HELL. Okay, anything else? I think these are enough. No, HELL is of length 4. No, we cannot select this right now, so not selecting. We have HLO, HLO, fine, of length 3. Now we can have ELO of length 3, and here also we can have ELO of length 3. So this is L is of index 2 and the next L is of index 3. Okay, index 2 and index 3 in the original string, and we can also have LLO as a substring. Okay, so do we have for k equals to 3 the common substrings that we can select for a equal to B? So yes, these two are same, HEL and HEL. HEO, no, you do not have another HEO, but we have HLO again, we have ELO, and if both A and B are equal, then this is also a subsequence. For k equals to 3 also we do have. Now do we have for k equals to 4? K equals to 4, what can it be? For HELLO. So let's see, HELO, HELO, they both are different for index 2 and index 3. Anything else? No, nothing. And we have ELLO. So this is one of the subsequences possible, that is ELLO, correct? This one. Anything else of h equals to 4? So what do we have now here? So for a equal to B, we can select HELO and we can select HELO, or we can both have ELO as the answer. That is, A is also this and B is equals to this. So obviously A is equal to B. So for k equals to 4, we do have an answer. For k equals to 5, the only substring is HELLO and A equal to B. Correct? So if A is also this and B is also this, then this can be an answer. So for all k's, we found out that it is possible to, in this example, to get a subsequence such that A is equal to B, such that A is equal to B. Now there is a condition. Now there is a condition in the question that says that you cannot select the same subsequences. That is this one. This case cannot be selected. Okay. Now what that condition says is, now let's see, for k equals to 4, we have H, E, L, L, O, and the indexes are 0, 1, 2, 3, 4. Correct? Now if we select E, L, L, O, okay, for A, we selected the index with 1, 2, 3, and 4. For B, we selected the index 1, 2, 3, and 4. Okay. Now here just count what are the common indexes. What are the common indexes? So what are the common indexes? How many common indexes we have? We have 1, 2, 3, and 4. 4 common indexes. Assign this value to a variable m. Okay. Now the question says that m plus 1 should always be less than equal to k. If this is true, then you can select that subsequence, else you cannot select that subsequence. Okay. M plus 1 should always be less than or equal to k. So k value is equals to 4 here. M value is equals to 4. So 4 plus 1 less than equal to 4. This does not satisfy the condition because 5 is not less than equal to 4. Okay. So you cannot select such subsequences. Okay. Similarly, we can see it here, this LLO subsequence, we cannot select it. Why? HELLO, correct? 0, 1, 2, 3, 4. So for A also, we selected 2, 3, 4. For B, we selected 2, 3, 4. Exactly the same. M value becomes 3. K value is 3. So 3 plus 1 less than equals to 3 becomes false. Therefore, we cannot select such subsequence. This also, we cannot select subsequence. Okay. So this here are the indexes. Okay. So what is M? M is the common indexes that we have used to create A and B. M is the common index is that we have used to create A and B. For example, now when we write HELLO, that is 0, 1, 2, 3, and 4. Okay. And it is HELO, that A is HELO and B is also HELO. Correct? These two. Now I told you these have different indexes. It is same 0, 0, E is same 1, 1. Now this A has chosen the L for the second index and B has chosen the L of the third index. That is the difference. O is same. So now tell me, what is the value of M? Now M is 1, 2, and 3. M is 3. K is 4. Now 3 plus 1 less than equals to 4. This satisfies the condition because 4 is actually equal to 4. So this equals to satisfy the condition. So we can select HELO as the answer. Okay, now H is at index 0, E is at index 1, L is at index 2, and O is at index 4. Okay, but in B, H is at index 0, E is at index 1, L is actually at index 2. So this is differing. And O is at index 4. Okay, so simply what the question is saying is you cannot select such subsequences which are formed by using exactly the same index. Okay, that is nothing but ELLO. We have to select there should be at least a single difference in the indexes. There should be at least a single difference in the indexes. So what the question is saying is you are given a string S of length n. You need to select two subsequences A and B. These two subsequences should be exactly equal. These two should have a same length k. Okay, these two should have same length k. And the next point is that m plus 1 should be less than equal to k. I explained you what is the value of m here, and what do we need to output is, after understanding all this, what do we need to output is we need to output the maximum value of k. Okay, maximum. For k equals to 1 we got our answer. For k equals to 2 also we got A and B. For k equals to 3 also we got A and B. For k equals to 4 also we got A and B. So we need to select the maximum such k. The maximum k equals to 4 is maximum. We need to select the maximum such k that satisfies this condition. Okay, so this was the problem statement. Correct? So we have given an S, N, and we need to select A and B. Okay, of length k satisfying this condition. Fine. Now this k we have to output. We have to output this k, the maximum possible k that is satisfying all these conditions. The maximum possible k that is satisfying all these conditions. This is the question. Now if you read the problem statement, it will be very clear for you to understand. Okay, you are given a string S with length n. Choose an integer k and two non-empty subsequence A and B of the characters of this string, each with length k, such that A equal to B. Okay, second point is let's denote the indices of the character using of A by A1, A2, A3 and B by B1, B2, Bk. If we denote the number of common indices by m, then m plus 1 should be less than equal to k. These 3 points I have explained to you. We need to find the maximum possible k, and if it is not possible, then we need to determine that no such k exists. Okay, we will see this case. This is just problem understanding right now. Okay, now these are the output. We need to find the maximum k or 0 if there is no solution. Okay, these are the constraints, pretty straightforward constraints. That t is equals to 100, n equals to 10 to the power of 5. So 10 to the power of 5 multiplied by 100 becomes 10 to the power of 7. So yes, we can use an order of n algorithm. We cannot use an order of n square algorithm. Okay, and n log n will be fine. These are the sample test case given to us, that is A and XA. Okay, so here in A and XA, you can see for k equals to 1, it is A and X and A different, also subsequence different, and we can select these two. Okay, now for k equals to 2, this is AN, AX, AA, NA, XA, NX. Nothing else we can find. So this is only the common subsequence, but this will not satisfy the condition of m plus 1 less than equal to k. So we have no such subsequence for k equals to 2. So there is no need to check for k equals to 3. We do have a subsequence for k equals to 1, that is A is also equals to A and B is equals to A. Okay, this is of index 0, this is of index 3. So yes, this condition will be satisfied, at least one should be different. So therefore the answer is 1. That is for k equals to 1 we get our answer. From k equals to 2 we will never get our answer. So for if k equals to 2 is not giving me an answer, so k equals to 3 will also not give me an answer. Okay, fine. So this was the problem understanding. Now we will take many examples, and we will see what is the pattern in the question, if there is a pattern. Okay, what can we generalize it, can we formalize it, can we find the subsequences directly in order of n time. Fine, let's now begin with the explanation. Now here let's see this. So if this is my string, so for k equals to 1, So if for k equals to 1 we get a subsequence of a equal to b, then we will check for k equals to 2, and then either we will not check. So as you can see, for k equals to 1, if a should equal to b and m plus 1 should be less than equal to k, to satisfy these two conditions we definitely need a repeated element. If the elements are not repeated, we will never satisfy this condition. If you want me to give you an example, so if we have a, b, c, d. Now see for k equals to 1. The subsequences are a, b, c and d. So is a equal to b? Yes. If m plus 1 less than equal to k, such this condition is not given to me, then each subsequence is equal to itself. If this condition is not given to me, correct? Now if we choose a here and b here, now a is at index 0, this is also at index 0, m becomes 1, 1 plus 1 less than equal to 1, this condition becomes false. So we cannot select the same subsequence, correct? I have explained you this. Now what do we need? From this we found out that if we have elements and all elements are unique, that is, there is not a single repeated elements in our array, in our string, then the answer is directly 0. Then the answer is directly 0. If we do not have any repeated elements, then the answer is directly 0. That is, for k equals to 1 to be true, we need at least one repeated element. We need at least one repeated element. Correct? A simple observation. Fine. So we do we have a repeated element? Yes, we do have. So a and a is repeated. So a and a is repeated 0, 1, 2, 3, 4, 5. So it is 3 and it is at 5. Okay, this condition satisfy m plus 1 less than equal to 2. This becomes a, this becomes b. Fine. Okay, for k equals to 1 we do have this. Now let's check for k equals to 2. When we check for k equals to 2, here just see this point. So if we have k equals to 1 and these are present inside the substring, for k equals to 2 also, this will definitely be there. This element will definitely be there. Okay, without this element we cannot have a substring. Without this element we cannot have a subsequence. Sorry, not a substring. Without this element we cannot have a subsequence, that is a equal to b. Okay, because this is the anchor point of that. Fine. So now for a, if I write, and this here also it is a, this is 3 and this is 5, the difference. Now I can add different elements. Okay, can I add e? Yes, we can add e. Can I add e here also? Yes. E, H, A. The sequence, the ordering in the subsequence should not change. G, A, correct. Can I write B, A? Here it is fine because B is coming before this A, but B is coming after this A, correct. B is coming after this A and before this A. So I cannot write BA here for the third index A, correct, because this will change the order, but in the subsequence order remains the same. Okay, so I cannot write BA here. This is wrong. So this is not possible. This is not possible. Anything else is definitely possible. Okay, except this, all the above three are definitely possible, correct. Now let's move to k equals to 3 for the next part. So for k equals to 3, here just check. For k equals to 3, okay, a will definitely be there. A will definitely be there. For 3 and 5, a will definitely be there. Let's see. Can I add EH to it to make it 3? Yes. Can I add EH here? Definitely. Can I add HG here? Yes. HG here? Yes. Can I add EG here? Definitely. EG here? Definitely. So for k equals to 3, I think these are my possible cases. I cannot add B anywhere. I cannot add B anywhere because B is coming after this A. So the ordering cannot change, therefore B cannot be added. Anything else is possible. Okay, so this is possible for k equals to 3. Let's check for k equals to 4. A, is it possible or not? What is my string? String is nothing but EHG ABA. Okay, it is, let me just zoom out a little bit. So it is EHG and ABA, correct. EHG ABA. So let's begin with now. So here it is, I can add E, H, G, A, all the three elements before A, and I can write here also E, H, G, A. So this is the third index A, this is the fifth index A. Anything else is not possible. Anything else is not possible. I cannot write E, H, G, A, A. You know why? Okay, n+1 condition will not satisfy. So for k equals to 5, I do not think anything else is possible now. So for k equals to 4, we do have a and b. Therefore, the maximum k for which a equal to b and n+1 less than equal to k condition satisfy is nothing but k equals to 4. I want you to observe this. I want you to observe this question, this example. Okay, we couldn't select b. The reason we couldn't select b was because b is coming before a repeated element, after a repeated element. Okay, it is a between in that element. Okay, we cannot change the order. We can select all the elements present after it. Okay, this is one observation, that we can select all the elements present before the repeated element. Okay, we cannot select the element present between the repeated element. Fine. Now let's take an example and see, can we select the elements after the repeated element or not. Okay, before and after can we select, then we will have a pattern. Correct. Let's take an example. So for example, we have a, b, c, b, d. Okay, now for k equals to 1, what is the repeated element present here? We are just taking right now the cases where there is a single repeated elements and it is repeating a single time, because I need to find a pattern first. I need to find something first to move forward. Okay, if I take these other cases, then it can break the point. Fine. So I'm just taking a simple examples right now. So for k equals to 1, we have a b, we have a b. It is at index 1 and it is index 3. Okay, it is possible to have a subsequence of k equals to 1. So for k equals to 2, is it possible to have a subsequence? Now for k equals to 2, can I add this a? Yes, this is coming before all the repetitions. So yes, you can add. We have ab and we have ab. Can I add c? No, we cannot add. Can I add d? No, we cannot add. So k equals to 2, this is the case. Now for k equals to 3, is it possible to have k equals to 3 in our case? Let's see. Now we can have ab, definitely. Correct, this AB or this AB. Can I add anything else without changing the order? Guys, think, can I add anything else without changing the order? Can you add C here? If I add C here, we will not have in this case the C after B. Correct. So we can add the elements before the repetitions and we can add the elements after the repetitions. That is ABD and ABD is perfectly possible. Okay, so given a string and some examples, you can take other examples also. I have taken when I was doing the question. So given a string, we can add the elements present before the repeating elements. We can add the elements present after the repeating elements. Okay, these are my repeating elements, but we cannot add the elements present in between the repeated elements, because this will change the order. This will change the order. We have some pattern here right now. Correct. So we can add the elements after the repeating elements, before the repeating elements, but cannot add the elements that are present in between those repeated elements. I hope you understood these two examples. Now we will move forward with another example. Okay, now we will see the test cases different from these. Okay, what we will see is when there are more than one repeated element, same element is repeated not twice but thrice or 4 times. Okay, we have more than 2, that is B is also repeated and C is also repeated. What we will do then? Okay, we have to check for each and every case before writing and before implementing. We have to check for each and every case. We do have a element in between right now. What if we do not have an element in between? Then what we will do? No element in between. Okay, or we do not have any element before. So before is 0. So this is before, this is mid, and this is after. So let's see. Let's write the cases here right now. So before is 0, that is no element before the repeated elements. Okay, we do have some elements. We do have some elements in the middle and in the after. Okay, we have an element in the before. We do not have any element in the middle. We do have an element after. Or this is also possible. Then now this 8 possibilities are provided. Correct. Now we have to come up with each and with this. Will this example, will this pattern that we found out, that just find the repeated elements. Okay, now count the elements before this, count the elements after this, and somehow you will get your answer. Correct. Will this work for all such cases? Will this work for all such cases or not? Okay, is it possible to work with all such cases? Now when there is no element before it, there is no element after the repeated elements. This is actually the case that they have given to us of A and XA in the sample example. in between the repeated elements we do have the elements, but we do not have before it or we do not have after it. Okay, in this case the answer was 1. Correct. So such cases we have to consider. See, this is very, very interesting. Okay, you have to think of so many cases, and after handling all these cases you will get your answer. And this is not difficult. Okay, in explanation it takes time, but when you are doing it, it does not take that much amount of time. Okay, it takes, but not that much. What you're thinking, it will take so much time and we need to think so much. But when you get an example or 2 or 3 example of each and every case, you will directly find a pattern. It will click. Okay, what is the formula, what is the generalization, you will be able to do it. Okay, now we will see many such examples and we'll formalize our question, and then we are going to implement. Implementation is the easiest part. This and problem understanding in this question was very important. Okay, let's move on and see different examples now. Okay, so let's now take another example. So this example we have already seen, HELLO. Okay, what is this case? When there are elements before and after, but there is no element in between. So what is the answer we got? We got HELO as the answer in the cases. Okay, so it is 0, 1, 2 and it is 3. L is 2 and L index is 3. Okay, as you can see in this example, we are only discarding the repeated element, and we are selecting each and every other element. So we select all the elements before them and we select all the elements after them. There is no element in the between. Okay, let's take more examples. So for example, we see A, B, D, C, C, D. Okay, we are taking a different example right now. So just a single element repetition, F. So we can select all the elements before it. I have explained. We can select all the elements after it. There is no element in between to discard. Okay, so the answer will be A, B, D, C, F, A, B, D, C, F, A, B, D, C, F. Correct. This C is different. Okay, it is index 3 and it is index 4. Fine. So m plus 1 less than case condition will satisfy. So in this case, you can see here that the answer is 4. Okay, 5. So when it was 5, the answer was 4, and when it was 6, the answer was 5. Let's take more examples. So let's take H, F, F, B. So in this case also the answer is nothing but HFB. HFB, as you can see, select all the elements before and after, no elements to skip in the middle. So this is the answer. For 4 it is 3. So obviously the pattern is very simple to understand here, that whenever there is no element in middle, whenever in the repeated elements there is no element in middle, okay, then in that case the answer is nothing but the length of the string minus 1. The answer is nothing but the length of the string minus 1, because we can select all the elements before the repeating element and all the elements after the repeating element. Okay, so in the middle there is nothing to skip, there is no middle element, so we will answer is nothing but simply n minus 1. We will only discard the repeated elements in each case. So okay, for till now this works, correct. Let's just write it down. Okay, so if there is no middle element, then the answer is n minus 1 between the repeated elements if there is no middle element, and when only a single element is repeating. Right now only a single element is repeating, correct. Now let's take more cases. Let's up it up a notch. So it is nothing but A, B, A, A. Now in this case a single element is repeating, but it is repeating more than once. It is repeating more than once, correct. It is repeating twice. Okay, now there are 2 cases here. Can you guys tell me? So till now what we were doing is we were finding the repetition. All the elements before it and after it is acceptable, and the element in between is not acceptable. So in this case the answer becomes AA and AA. Okay, 0, 1, 2, 0, 3. Sorry, 0, 3 and 2, 3. Correct. The index 0, 3, this one and this one, or 2, 3, this one and this one. Okay, this is the answer. Okay, but you guys can see the actual answer is ABA and ABA. That is, this A 0, B 1 and 3, and 0, 1 and 2. This is the actual answer. This is the longest string that we can get, not this, but this, for k equals to 3. Now we have 2 cases. In the first case we considered that whenever there is a repeating element, find the repeating element, and in the middle if there is an element, skip it. But here we found out that just now we found out that there can be 2 cases in the same string that we have a repeating elements, but it is repeating twice. Now we have a b a repeating twice. In the first case we do have a middle element, but in the second case we do not have a middle element. So which one we need to choose? We need to choose the one that is giving me maximum k. Okay, so in the first case we do have a repeating middle element, but in the second case we do not have a middle element. Okay, now if we do not have a middle element, the answer is simply n minus 1. That is nothing but 4 minus 1 3. But if we do have a middle element, the answer becomes 2 here. Correct? Fine. So which is giving me the maximum case? The maximum answer is given to me when there is no middle element. Correct? Keep this in mind. Fine. So for example, if we have a case where we have a b c b, okay, b d f, so either we can select this or we can select this. Now I think you know which will give me a maximum result. It is a b c b d f and a b c b d f. Now this b is this and this b is this. Okay, so whenever we have such cases, then we can have n minus 1 as the answer directly. Now there can be a different case here. So here there was one repeat element and here there was 0 repeating element. Correct? What if it is a b c d b and now we have f and then we have b and then we have e. Now what will happen? Now we do have repeating elements. A single element is repeating thrice. Now we are just focusing on a single element case. Single element is repeating thrice. Correct? Now here there are 2 elements in between and here there is 1 element in between, which we will need to choose. Come on, think. I think you got it. So which element we will need to choose? We have 2 elements in between. We have 1 element in between. We have 1 element in between and we have 0 element in between. In the previous case, we have 1 element in between and we have 0 element in between. So which we chose? We chose the minimum one. So when you get this, then in that case, whenever there is a repeating element, okay, and we need to choose that repeating element, okay, that repetition that has the minimum possible middle one, because this middle one will definitely be discarded. This middle one will not be applicable anywhere in the code. Correct? So as much possible we need to reduce this number of elements, okay, because in our final string of a and b these will not be included. Okay, so if we can reduce them, so if I choose this, 2 elements will not be included, but if I choose this, only 1 element will not be included. Obviously the length here will be greater. We are discarding only a single element, but here we are discarding directly 2 elements. Obviously the length here will be greater, where the answer will be a b c d b e and a b c d b e. Correct? This b is this 0 1 2 3 4 and here it is 4 5 6. Okay, if we discarded c and d, then the answer would become a b b f this and this. Correct? a b b a b f b e and a b f b e. Okay, this would become, this b is nothing but 0 1 and this b is nothing but 0 1 2 3 4. Who is greater? This has 6 elements and these are 5 elements. Obviously this is greater. Correct? Because here we discarded just a single element, that is f, and here we discarded actually 2 elements, that is cd. So we need to reduce this, how much we are discarding. Therefore whenever you have a repeated element, whenever the case that we found out was in a single element is repeating many number of times, then we need to select that window. That has the minimum possible middle element. Okay, now if that middle element is 0, that is we do not have the middle element at all, that is nothing but a b a case, then the answer we found out was directly n minus 1. Okay, now I think you know, if the middle element is n, or if the middle element is, let's say, k, that is k number of times the middle element is occurring, there are k middle elements, then the answer simply becomes n minus 1 minus k. Okay, n minus 1 minus 0, n minus 1 minus k. Here mid was 0, here mid was k. Okay, so the logic becomes n minus 1 minus mid. N minus 1 minus mid is the answer. Correct? So just find out what is the value of this mid element and put it in this equation and you will get a answer. Till now what we have seen, we have derived this. Till now with the equation that we have seen, we have derived this much part. Okay, now but we still have to consider the case where there are more than one repeated element. Okay, that is two elements are repeating. That is, for example, B and C are repeating. For example, we have A, B, C, D, C, B, F. Now in this case, what we will consider? Will the formula change? Will the formula remain the same? We need to consider all these cases. Okay, you cannot just write it down directly. We need to consider all these cases. Now next we will consider this case. Okay, let's see here. If we select B as our repeating element, we need to discard 3 elements. But if we select C as our repeating element, we need to discard just 1 element. And this is a no-brainer, guys, that we will definitely select C. We will definitely select C. This is a no-brainer. Okay, what do we found out? That our logic is completely correct for this example also. That if we select the repeating elements, we need to select those repeating elements that have the minimum possible mid. And that will give me the answer. Okay, we need to reduce mid to increase the value of k. Correct, the length. Fine, we need to reduce this mid. Anyhow, fine. So once we find out that yes, B is also repeating and C is also repeating, but which have the most minimum number of middle elements, that we need to select. Yes, B is also repeating and C is also repeating, but which have the minimum number of repeating elements, that we need to select. Okay, and then just find the number of middle elements and put it in n-1 minus mid, and that will give me our answer. Okay, so now what we do, we have covered up the cases of before, after, mid, which we need to select if more than one element is repeating, which we need to select if a single element is repeating many number of times, and the same will go if many elements are repeating many number of times. Okay, many elements are repeating many number of times. So here, whichever repetition has the minimum possible gap. So here, if this one B also I add, now this will not be selected, but this will be selected because here mid is 0. Okay, so we need to find such gaps. Okay, the minimum possible gap, minimum possible mid value. Okay, minimum possible number between the two repeating elements, and that will be our window, and that will be our answer. Okay, once we find that mid, just substitute it n-1 minus mid, and the question will be solved. There are so many cases to consider in this question. Correct. So let's now think of a logic of now how we will find out this. Now we know by just writing on a paper or on a sheet right now on a software that yes, this is the answer. Okay, this is how we will do it, but how we will implement it. Now comes the implementation part. We understood the question, we understood the logic, taking so many test cases. Okay, now third part is how we are going to actually implement the logic that we have thought of. Okay, now I will begin with the logic implementation. Fine, so let's see the implementation now. Now during the implementation, we need to take care that our complexity will not go beyond order of n. Okay, it cannot go order of n square. Fine, we need to find the repeating elements. We will find the repeating elements. Okay, we need to find how many elements are present between those two elements. Formula is direct in that case, as you can see here. So if I have index 2 and index 6, how many elements will be present between these? It is nothing but 6 minus 2 plus 1. Okay, 6 minus 2, that is 4. 4 plus 1 is 5. That is how many elements are present? We have 6 minus 3 is 3. 3 plus 1. Okay, 6 minus 2 minus 1. So it is nothing but m minus n minus 1. That many elements are present. If this is n, this is m. So we have m minus n minus 1 number of elements are present between any two indexes. Okay, so just find out what is the first occurrence index, what is the second occurrence index, what is the third occurrence index, and so on, and what is the minimum number of elements present in those indexes, and we will get our answer. Correct. So how did I go on this? Is it can be order of n square, but we will go to the order of n only. So first, G, is it occurring anywhere before it? No. How you will find it out? Okay, so take another array. Okay, in that array we will store what we will store. We will store the occurrence where it came before, it. Okay, and then we will subtract it with the current index, and we will get our answer. So there will be two things: the minimum value and another array of last occurrence. Okay, has G occurred anywhere before it? No, it has not occurred. It is occurring where right now? It is occurring at index 0. So update it. Okay, has L occurred anywhere before it? No, it is occurring for the first time. So update its value in the last occurrence, that L had occurred at index 1. Somewhere L has occurred at index 1. Now D, has D occurred before? No, update it to 2, that D has occurred at index 2. For I 3, that I has occurred at index 3. Now check L. Has L occurred anywhere before? Yes, L has occurred in the last occurrence array at index L using the ASCII characters. So we will map it out. So here L has a value of 1. That L has occurred at index 1 before, and now L is repeating. That means L is occurring at index 4. L is occurring at index 4. Okay, L is occurring at index 4. L has already occurred at index 1. So what will be the number of elements? 4 minus 1 minus 1. That is, in between they have 2 elements. That is nothing but D and I. In between we have 2 elements. Now in the min, update this value. Okay, that means we have 2 elements in between. Fine, and update this value as 4 now. Okay, that the last occurrence of L was 4. If there are more occurrence of L, this will be helpful. A will be 5, no occurrence before. Now for 6 has occurred at index 3. Okay, now it is occurring at index 6. How many elements? 6 minus 3 minus 1, that is nothing but 2 elements. So min is already 2, no need to update it. Update I. That I is occurred before at now 6. Now F has occurred before? No. Has I came before it? Yes, I came last at index 6. Current index is 8. How many elements between them? 8 minus 6 minus 1, that is nothing but a single element. Is min 2? Is min is less than this? No. So update min. That is, now update I. Now you can see what I was doing is here simply that now we know that min is 1. That means between these repeating elements, the minimum repeating middle element we found out between the index 8 and index 6. Okay, and we have stored that value, the min value. Okay, or you can say the mid value. Now D has occurred before? Yes, D has occurred at 2. Currently it is 9. How many elements? 9 minus 2 minus 1, that is nothing but 6 elements. Okay, mid is 1, it is 6. Obviously mid will not update, but D will update for the further references. Okay, so this is how we are going to work. We will take a last array. Okay, now in this last array we will going to update what is the last position that element occurred. We are going to update at what last position that element occurred. Okay, and if it has occurred before, we will just subtract it with this current index, and with the last index we will find out how many elements are present in between them. Okay, because that many elements we need to discard. Correct. Now we found out that the minimum number of elements that are present between our repeated elements was a single element F. So a single element, so n minus 1 minus that single element min. So it will be n minus 1 minus 1, n is nothing but 10. So 10 minus 1 minus 1 will give me 8. So k value is here 8. That the largest subsequence of A and B can be found out with k as 8. The length will be 8. Okay, and what it will be? It will be simply from G to this I and then this D. Okay, or G to E, then I and D. Correct. So here that is our final answer. Okay guys, I hope you understood how we will calculate our last array, how we will calculate our min. Okay, using the last array we are just storing that last where that element occurred. We already know where this element is occurring right now using the loop. Okay, we know where this element has occurred last. We will subtract, we will get how many elements are present in between them, and we will store only the minimum number of elements that are present in between any of these repeated elements, and that's it. Now how this last array will work? This is nothing but the ASCII ones. So we just have 26 alphabets. Correct. So A, B, C, how you will map A to 0, B to 1 and C to 2? If you know, that's very good. If you do not know, this mapping is nothing but using the ASCII characters. So in the string at the index I, okay, if the element is A, subtract it with A. Okay, if whatever the element is, you need to subtract it with the ASCII value of A. The reason being, ASCII value of A is 97. If the character is B, its ASCII value is 98. 98 minus 97 is 1. So 1 will now represent B. 99 minus 97 is 2. So 2 will now represent C. And 97 minus 97 is nothing but 0. So 0 will now represent A. Okay, so subtract it with the ASCII value of A. Any character that you get, subtract it with the ASCII value of A. This will become B, C, D. Okay, subtracted with the ASCII value of A. So the last array at stri minus A will give me the index where I need to update the last occurrence of that element. Okay, so this was the implementation part. It is obviously just order of n. Once we get this, this is order of 1, n minus 1 minus mid. Okay, so this was how we are going to solve this question of subsequent play. Okay, now I'm going to show you the implementation in Java. This is the same implementation you can do in C and C++ also. Fine, let's see the implementation. Here you can see that I'm taking the test case input, then I'm taking n input, then I'm taking the string as the input. Okay, now this can vary with C and C++ how you take the string as the input. Now the minimum, that's to store the minimum number of elements that are present inside my array. Okay, inside the repeating elements. Now the last occurrence array of the length 26. Okay, initialize all that with the integer dot minimum value. Right now no one is repeated. This is the meaning. Okay, now for n times the loop will run. Okay, now if the last occurrence of that character is the minimum value that we have stored, that means it has not occurred till now even once, update that. Else if it has occurred, then calculate how many elements are present between this and that values. Okay, update it and update the minimum value and update the minimum value. Simple, that's it. And after you get the min, simple, this system.out.n minus 1 minus min. Now here we will do n minus 1 minus 1, correct? So that one I have subtracted here, that one I have subtracted here. You can subtract that one here also. Okay, whatever min value you get, you need to subtract 1. Okay, because I have not subtracted it before, I had subtracted it here. Okay, what is the zero case? That means if no element is repeating twice. If no element is repeating twice, min will remain, min will not update. If no element is repeating twice, it will never come to else, min will not update, therefore I am writing 0. Okay, that is no element is repeating, there is no subsequence that we can select, therefore the answer is 0. Okay, a simple direct implementation. Implementation is not that difficult, but the explanation and the logic, I hope it is very clear. Okay guys, thank you.